Greetings from Camp Kalakwa, Florida. We're going to start here now with the Water Science Honor. Camp Kalakwa, I am Keith Nelson, Wildlife Sanctuary Director, and we're going to be going over some science-y stuff with water and water science. So what we want to do first before we begin is just make sure we're on time here and we're rolling. We got a couple minutes. I don't want to cut anyone off here before 4 o'clock. So in the 2 minutes before, I want to ask some questions to those that are in the door. Do you have a copy of the worksheet, and are you ready to go with it in front of you so you can put down the answers and write them down and earn the honor? If you want the little badge and the honor patch, then you need to complete the worksheet that is at iRedZone.com under the honor Water Science. Look for Water Science Worksheet. We're going to have to move through this one because this is one of the longer ones. This is a good one to do today. It's a beautiful day to work on water science, but this does get into some detail and some exact science stuff with water. And so as we look for it now to be almost 4 o'clock, we're going to go ahead and start with a word of prayer. Let's begin. Kind Heavenly Father, we thank you so much for this wonderful world you created and for water and its unique characteristics. Today, as we look at it, give us your wisdom and a deeper appreciation for you, our Creator, our Father, and our friend. In Jesus' name, amen. All right, this is one of my favorite honors. Water science has a lot of fun to it, and we're going to dive right in by doing a screen share of some pictures that you can see. Let's put some pictures up here for you. And the first thing we want to do is move that. Does that work? Or can you see that? Okay. All right. So the science behind water is amazing. Let me just introduce it to you this way. There is no other liquid on Earth that has the same properties of water. There's a lot of liquids that are close. But for instance, every other liquid in the world, if you freeze it, the frozen solid part will sink in its own liquid. Every day we might take a cup of water and put some ice in it, and the ice jingles and floats on top. And what's interesting is only water does that. Think about it, a solid that floats in itself. Something that's solid floating in its own liquid. And if that didn't happen, we would all be frozen to death on Earth because the ice would sink at the bottom of the oceans, freeze that water, and more would sink. But because ice floats and is less dense, we have a relatively nice warm planet to enjoy and share and work with here. So let's dive right in. What's neat is you can do this with anything. I suggested toothpicks and gumdrops. But water is made up of 1 atom of oxygen and 2 atoms of hydrogen. So here in the picture, the little red gumdrop is oxygen, like was found in your blood. So that's why it's red there. And then the hydrogen atoms would be like the bunny rabbit ears of the jelly beans or the other gumdrops. I like to call it the Mickey Mouse molecule, because if you've ever seen a picture of Mickey Mouse with his face and his 2 big round ears, that's what the water molecule looks like, because the 2 hydrogen atoms joined to 1 oxygen atom for H2O forms a compound, which means, please move this window away from the shared application. Oh, okay. Don't know what that is, but it's there. Maybe I can stop share and see if I can fix that. Hold on just a minute while I do that. We're going to do a little housekeeping here and see if we can get that box to disappear. And I need screen sharing permission, apparently. Huh. I've lost it. There it is. Let's try that again and see if indeed we are no longer getting that box. Is that better? Sorry about that. So the water molecule being two little circles at right angles on one big circle looks like Mickey Mouse. You can draw this on your paper. You can make it out of anything you want. Here, I did gumdrops. And gumdrops are easy to do with toothpicks. That's what water looks like as a molecule. So we're going to describe the water characteristics and how it differs from all other elements. Here we go. I believe that you'll find this on your worksheet if you're following along as number 2. And number 2 is this: water doesn't smell like anything. That means it's odorless. It shouldn't have a taste. Now, I know here in Florida and some other places, you can get some real sulfur in the water, or maybe a sulfur odor. And water, natural water, does not have a taste. It's colorless, it's tasteless, and it's odorless. By the way, water refuses to change temperature. If you put water on to boil, it's going to take it a while because you have to raise every molecule of water up a degree, and it doesn't like to change temperature. It's a great insulator. It has resistance to temperature change. We already said that it also floats in its own liquid as a solid, and that's unique. And by the way, hydrogen is the first element on the periodic table, and water is a lot of hydrogen, and hydrogen has only 1 electron, 1 proton. It's very unique stuff, very simple, and yet so necessary. Your next section here asks you to look at these photos, and we're going to leave that photo illustration concept on the left, and we're just going to change the photo on your right. So if you're looking at ice as a solid, it's going to be very linear and orderly, almost like soldiers marching in a regiment, or like chairs lined up for a meeting, and there's going to be some speaker up front saying something wonderful. And all these little spaces and dots are equally distanced apart. That is, that they're all uniform, like a soldier, like we said. That's solid, that's ice. And by the way, it expands a little. That's why ice floats in water, because those molecules push apart when they freeze. They're like, get away from me. It's like dress right dress in Pathfinders. When you stick your arm out and you're exactly 1 arm's length from your partner, that's ice. Liquid's different. You see, these molecules can be anywhere, but they're pretty close together. And they follow a string. Remember this, write this down, the string model. That means that you can pour liquid and it actually pours out in a river or stream-like pattern. And you can actually do this at home to find out how much of a stream and how they like to pull together. Like, imagine you roller skating and everybody joining hands, and you don't want to let go, and you become a string of people. Well, try this at home. On a day when you have good air conditioning, or it's not too humid or not too wet, take a plastic comb and comb it through your hair a lot. Then turn your faucet on in the sink and make just a trickle stream come out. Not a big rushing whoosh, but a tiny trickle. Comb your hair and then put the comb next to the water without touching it. And that water will bend towards your comb, because water is attracted to electricity. And it also, you're building up static electricity on the comb, and it also is like joining hands and carrying and holding together all the way through. Someone's writing. So now we're going to go to the gas, the third state of matter, where it's a vapor. Now it's like the boiling water in the pot, and that steam is coming up from there. And that stuff's different and causes the molecules to be further apart at that point. That means that they're just bouncing off each other and going all over the place. I wonder where that line came from and how I can get rid of it. If I go out, something to work on. We'll work on that. Sorry about that. Someone must have scribbled on the screen, and I don't know how they did that. So next up, we're going to describe the difference between clouds, snow, and rain, which is a trick for Floridians to do. You know, I was probably 23 years old before I saw snow. Maybe some of you have never seen snow. But a cloud is made up of tiny water droplets. And when you can fly through them in an airplane, or you've felt them, you've run through a cloud, because fog is a cloud. It's just a cloud that's come to ground. So these water droplets or ice crystals that form in the air, we call clouds. Now, a snowflake is tons of little ice crystals that join together in the hands, just like we did with our demonstration of roller skating. And it is true that no two snowflakes are exactly identical. They form as they attract each other, and it grows in the cold, moist air. So what we're going to do is we're going to list the types of precipitation and see if we can identify what we're looking at. People that live up north where it snows a lot have a hard time telling sometimes the difference, say, between sleet or freezing rain. There's very subtle differences. Let's take a look. In Florida, we get rain. We're expected to get some rain today. In fact, some of you watching in the viewing area might be getting rained on right now. Rain is simply water droplets, but not that, it's more than that. Rain is formed around a dust particle or a tiny particulate in the air. So in order for it to rain, you need water and you need little particles in the air for the water droplet to form around that will carry it to the ground. When it comes to the ground in liquid form, we call that rain. Snow is also a form of precipitation. Precipitation is a big word that means falling out of mixture. So you can have a precipitate when you go and mix sand and water, and you stir it and it makes mud. And then you wait a day and the water's on top and the sand's on the bottom. That means the sand fell out of the mixture. It precipitated down. So rain and snow falls out of the mixture of clouds and becomes precipitation. And it is composed of little tiny ice crystals. Now, and we're back. Thank you, Charles, for that bit of information. Didn't know I'd accidentally scribbled on my own drawing. That was a new one. Been using PowerPoint for a while, but I guess not in screen share mode. So let's recover that again and go over that. The snow is composed of ice crystals, rain is liquid, and sleet is simple. It's a mixture of rain and snow. I may have to go out to remove this window again, is that right? Freezing rain actually covers everything with ice. So if you get up in the morning in the North Country and you see the trees and the bushes and the power lines all covered with ice, you know that you've had freezing rain through the night. And it builds up on itself so much that sometimes it gets so heavy that it breaks the wires or the lines. And freezing rain can be extremely dangerous. It can actually break lines, power, tree limbs come down on houses. Hail is different altogether. Hail is in the form of an ice ball or an irregular shape of lump of ice. So then most hail is probably, let's see if I can move that, anything 5 millimeters or smaller or larger, I guess, or more is considered hail. Hail damages everything it hits. You can get hail damage in the car. I've seen it break windshields with people driving down the road. The next point that we come to is the freezing point and boiling point of water. Now, we in America, we like to use a measurement of temperature called Fahrenheit, named after the gentleman that identified this, but that's random. really Fahrenheit is complex and hard to understand. Celsius, the C there, makes more sense to say 0 degrees is when water freezes and 100 degrees is when it boils. Well, 0 is the same as 32 Fahrenheit or 212 on the Fahrenheit scale if you're boiling. So boiling water is hot enough to cause 2nd and 3rd degree burns to the human tissue and skin, which is why boiling pots of water and kids don't mix. It's very dangerous. Interestingly enough, I want to note here, see if you can follow me. The freezing point of water and the melting point of water are the same. You melt ice at 0 degrees Celsius or 32 degrees Fahrenheit, or you freeze water at 0 degrees Celsius or 32 degrees Fahrenheit. So it's either coming or going at each point. So the freezing point and boiling point should be easy to note down on your sheet there. Next, we're supposed to understand how much of the earth is covered by water. Now, you probably heard a lot that 3/4 is about 75% is about accurate, but it's a little more precise than that. It's really less than 75%. It's more like 71%. And what's interesting is of all that water that's out there, only 2.5% of that is fresh water. So all the water we drink, swim in, pools, lakes, ponds, huge lakes, Lake Michigan, Lake Superior, these massive freshwater lakes only represent 2.5% of the water in the world. And of that, 98% is ice and groundwater. Okay, so where is all this water on the earth? So the worksheet is maybe not following the slides is what I'm showing. So let me see if I can follow you. Let's take a look at the worksheet. I am on where am I? I'm on number 7. No. Let's see, I am on letter A. Number 8, I can't read very well. Sorry, I'm on number 8. I need to keep all this straight. 96.5% of the planet's crust water is found in seas and oceans. So most of this water that's on this planet is covered in the oceans. Only 1.7% is groundwater and another 1.7 is in ice, glaciers, Greenland, that kind of thing. An even smaller fraction is in the air that you breathe, and what you're breathing right now has water in it. I'm gonna look around here. Okay, I'm on number 12. Apparently we're playing Skip to My Lou today. Number 12, what is a body of water? So through diagrams and things, we're going to discuss what different bodies of water there are. It's pretty common sense. A river is a natural flowing body of water, usually flowing toward the ocean or sea. A lake is a variable sized area of ground filled with water, and the sea is a large body of salt water, also known as an ocean, that covers much of the earth. Continuing on number 12, a rapid, a section of water that moves quickly and is turbulent. We're just supposed to be able to draw it. You don't have to define it, just draw it. A canal is a man-made channel, usually straight lines going through the ground. A creek is just smaller than a river, and it's anyone's guess as to what that means, because a very small river can still be considered a river by one man and a creek by another. There's no scientific definition between the two. A basin is just a term that refers to a dip in the land where water gathers. A gulf is a glacier is a large body of water in the form of ice. A gulf is a bay that sticks into an area of land such as the Gulf of Mexico, and its shape in America. A harbor is a small version of a gulf. It's just a tiny little area where ships can shelter. And a lagoon is a shallow body of water separated from a bigger area of water. So just a small, shallow area of water separated from a big area of water. A reservoir is an enlarged, natural, artificial lake where people store water, like in Southern California, for drinking. Man-made reservoirs are everywhere. They build a huge dike or dam wall that will keep the water in. So we're going to just show those three real quick again. Be able to think about drawing the only difference between a reservoir and a lake is one is usually man-made. There are three Bible texts that we want to look at real quick here that has to do with science of water. And that number is number 13. So we're going to discuss now these different things, number 13. It just says to discuss. So you just check there as we talk about these things. Revelation chapter 22, verse 1 isn't there. Okay, so we're going to go to Matthew. Which one's on your sheet there? Matthew 28:19. Is that right? That's right here. Sorry. Go therefore and make disciples of all the nations, baptizing them in the name of the Father and the Son and the Holy Spirit. So what we're saying is, in the study of science of water, there's something magical that happens that we would be remiss or mistaken not to study here in Pathfinders, as we believe that water has the power to symbolize or represent the Holy Spirit and a new birth that we can have in washing in it. So we believe that baptism, in the form of going all the way underwater, is an example of how we are accepting Jesus and showing that we're being buried to self and risen with him. And so that's one study of water in the Bible. John 4:14 says, whoever drinks of the water that I give him will never thirst. But the water that I shall give him will become a fountain of water springing up into everlasting life. This has to do with Revelation that we were going back to a little bit ago, showing me a river of life coming from the throne of God. John 3:5 isn't listed in my screens here, but I'll read that one to you and we can read it together, and we can do a few verses here. John chapter 3, verse 5, and this is what it says. Verily I say unto you, said Jesus, except one of ye be born of water and the Spirit, he can't enter into the kingdom of heaven. So John 3 and 5 also refers back to baptism as well. Water has power to cleanse, power to clean. It represents cleaning power. Water is the universal solvent. It breaks down all substances. If you leave water touching something long enough, it will slowly break down and remove whatever it touches. So there are some ways that water is used, and I think that this is number, let me see here real quick. Sorry about the confusion. I had to take a section out of this as we were going. Okay, number 11. Number 11 says select 3 ways that water is used. So we're going to choose these 3, A, B, and C, if you can read it. Number 1, in agriculture, you can make that a simple word. You can just say farming. And that means that water is used to produce plants and food like potatoes and tomatoes and cucumbers and watermelon. And so we use water to grow. Now it's interesting, it takes nearly 700 gallons of water to make 1 watermelon. So it takes a lot of water to grow these plants that we love to eat and enjoy. And so if you're going to be a farmer, you have to think about moving thousands of gallons of water over your land, especially if it doesn't rain and you're in a drought. The second one is washing. Water is used heavily for washing. We talked about the cleaning power of water earlier, and it takes about 5 gallons for every minute of washing that you do with the dishes and the dishing, if you're washing dishes in your sink. And in order to use water to wash you in a shower or a bathtub, by the way, it uses often less water in a bath than it does a shower. Showers generally use more water. People like to spend more time in the warm water in the shower, and it uses a lot. Drinking, obviously, everything that we drink is mostly water, whether it's a power drink or a soda from a soda fountain. When we drink, we're drinking water mixed with different sweeteners, colors, and different things. So that maintains body temperature and helps you regulate and keep healthy with blood circulation and everything going on there. At the very end, and we're not at the end yet, but at the very end, we're supposed to understand how to convert salt water into drinking water. If you're lost at sea or you're near the ocean and you're thirsty, don't drink the water. It's the worst thing you can do because the salt in the water will dehydrate you, will pull the water out of your cells that you do have. So salt water cannot be drunk. And what you need to do is distill it. That's that first word there, distillation. In order to do that, you have to boil the salt water and make it turn to that vapor we were talking about earlier. If you trap that vapor on a cool surface or glass above the boiling water and let it drip down into a clean cup. So you first boil it, trap the vapor, let it drip down, not letting any of that water fall back into the pot. Then you can place that lid upside down on the pot so that the handle faces down over the mug. And then bring the water to the boil again. It will evaporate and condense on the lid as liquid water. Whatever you trap above has no salt in it. You see, the salt won't evaporate up in the vapor. That's why rain is fresh water. Even though it originates in the ocean, when it evaporates up from the seas and becomes a rainstorm, it doesn't bring the salt with it. So in order to remove salt from salt water to drink it, you're going to have to boil it, capture it, condense the vapor, and turn it coolly back into liquid again. So it's going to be boil, trap the vapor, and cool the vapor. Boil it, trap the vapor, and cool the vapor. And that's what makes this process that we know of as water. Now, let's go back at your worksheet and see what we're missing. We've done number 1. We've done number 2, 3, 4, and 5, and 6. Now we come to number 7, right? We haven't done 7. So what we're going to do is we're going to have a little fun with that right here for a minute. And we're going to stop screen sharing and jump back into Camp Kalakwa's view here for just a minute. Is that normal there appearing on your screen? So let's go over some trivia with water. Water is so fascinating and can be fun. Let's just think about some of this for a minute. If you know the answer to the question, let's see how many that are listening can type the answer in on a chat. So get ready to open a chat and let's see how many of these you can answer. How much or what percentage of the human body is water? Now we know 71% of the earth is water, but how much of our body? Oh yeah, is water. I'll go back to the first one. How much of our body is water?
So since it's 68, 75, 70, 75, 60.
Who said 68? Can you name them?
68 is person number 12.
All right, person number 12 takes the cake. You're the closest. It's actually somewhere between 65 and 68% ideally, but a lot of us walk around dehydrated a lot. In fact, most people don't have that, and they're sitting closer to 60% every day. So you really want to be 65 to 68%. Good job, whoever said 65 to 68. Oh, a shout out to Jacksonville Trailblazers. Way to go. All right, let's go back to the first trivia question. What is the estimated weight of 1 gallon of water? That would be the same as 4 liters. Like if you ever held out a whole gallon milk jug with one arm, you know it's hard to do. You know it's not light. So take your guess. How many pounds would 1 gallon of water weigh roughly? See who comes in. Anyone guessing? Someone's got 7. Getting close.
8 pounds.
Okay, who said 8 pounds? Give me a name.
Number 6.
All right, number 6, where are you from? Jacksonville, Spanish. All right, Jacksonville, no, that's someone else.
Hollywood Spanish.
Oh, Hollywood Spanish. Way to go, Hollywood Spanish, you got it. 8.34 pounds to be exact. But we like to roughly say 8 pounds. All right, jumping down to letter C, what is the largest ocean on Earth? Shoot it out. That is correct. Everyone got that one correct. The Pacific Ocean. You knew that one, didn't you? Letter D, what is the largest lake in the world? Anyone know? I'll give you a hint. It's not in America. You're going to have to go outside of America to get this. Largest lake in the world by area.
Somebody got it, number 3.
Number 3. All right. Caspian Sea, you are correct. Give yourself a high five. It is the Caspian Sea. What is the largest lake in North America? All right, what is the largest lake? Now this one is here in America. What's the largest one? Now we know it's probably, yes it is. Hence the name Lake Superior. Number 6 is flying here. I'd like to know what grade number 6 is in. Can you say what grade you're in, number 6? 10th grade. Oh, of course, we got us a biology major ripping through here. You just finished biology or you're going into it here? Good luck with that one. I know you'll do well. What is how fast can sound travel through water or air? Which one does it travel through faster, water or air? That is correct. It travels faster through water, much faster through water. In fact, if you've ever been swimming in a lake and you heard a motorboat coming, you can hear that like it's coming right on top of you, but it can be 100 or 300 yards out. What is the deepest point in the world's ocean, and what's the name of that place? The deepest place in the world. Number 1, way to beat number 6 out there. What are you doing here? All right, number 1, you are correct. It is Marianas Trench, and it's just off the coast of, I think it's off the coast of Japan and Russia over there. It's on the western side of the Pacific. What is the longest river on Earth? Does it not? I didn't say the largest, the longest river. Someone is saying Nile, and you are correct, the Nile. Someone's got Google up. Turn your Google off. How long can a person survive without water? Well, there was a world-breaking record of 4.5 days, but really we accept in science 3 days. 3 days is the longest a person can survive without water. Okay, you've heard of hard water or soft water. Okay, for letter J, what is it that makes water hard? Anyone know? You can be right. Oh, someone got very specific. All right, grade. What grade is number 1 in here? Calcium is correct. So, what grade is number 1 in? Is that maybe that's a? They're not wanting to say. They're an adult. They're out of school. Just kidding. The presence of calcium and magnesium in the water, or elements, metallic elements, makes water hard. You have to add salts or electrolytes to water to make it soft, by the way. What uses the most water in household? Do you think it's the toilet, the shower, the washing machine, or the dishwasher? What is it? You are correct. I think I kind of gave that answer away earlier. The shower uses nearly 30% of household water. So start taking quicker showers, people. What is the word used to describe how much water vapor there is in the air? Water vapor in the air is called humidity, relative humidity. Way to go. Number 1 and number 6 are in a stiff competition. I love this competition and response, by the way. What is the name of the canal that connects the Pacific Ocean with the Atlantic Ocean? That is correct, the Panama Canal. Given to Panama and built by America. By the way, a little bit of trivia while we're at it. We're just finishing a new Panama Canal that's much, much wider, and they're finding some really cool fossils down in that area as they cut through. You might want to look that up. It's fun to watch. They might be done by now. I haven't figured out when they're supposed to be done or if they are done. Which conducts heat more efficiently, water or air? And water conducts heat 25 times more than air. You are correct. Water is more efficient than air by the level of 25 times. So how much water does the average person drink a day? Well, that's different from how much are you supposed to drink. You're supposed to drink 2 liters, but most people drink 1 liter or less a day, which is really sad. What you need and what we're doing is very different. In fact, there's a whole lesson we could teach just on drinking water. And excuse me, I need a drink. Yes, much better. And drinking water and its ability to help you fight disease and keep balance in your body. You're right, number 12, it does depend on the person. And so what we're doing is we're taking the average build and weight of a person. So it's about a ½ an ounce for each pound of body weight. So the more you weigh, the more water you need. You wouldn't want to shove those 2 liters into a baby. That is correct. So what chemical is added to water to kill harmful germs? Chlorine? Trick question. You are correct if you're thinking swimming pool. But what do we use in hot tubs and spas? Does anyone know? Chlorine is for cold pools. When the water is hot, chlorine doesn't dissolve as well, and it takes, anyone know what chemical is used in spas and hot tubs? It rhymes with chlorine, starts with a B. It's another element on the periodic chart, and it's not bleach. You wouldn't want to put bleach in it. Chlorine is close. Well, it's called bromine. Like, yeah, bro, that's mine. Bromine. Perfect there, number 1, except for no W. You're getting closer to a brownie, and you're making me hungry. All right. What is the largest navigable river in your country? Oh, wait, that's not the next question. How many gallons of water are used in a 5-minute shower? So if you're just doing 5 minutes, you're looking at about 10.5 gallons. In other words, you're using 2 gallons a minute on the average. So number 11, if you wrote 2 there, you're probably thinking 2 gallons a minute. All right. What is the longest navigable river in your country? The Mississippi, explored by Mark Twain, Samuel Clemens, and many stories running up and down on the eastern side of the United States. True or false? Water is often called the universal solvent because it dissolves everything, and I already told you that that is true or true. Sorry, that was just good stuff. I'm glad someone else can misspell. You're just trying to make me feel better, as I know I can misspell as well. At the very end of the sheet, you're supposed to know how to turn salt water into drinking water, which you've done. I'm looking at the time as 4:36. And so I think you've done tremendously well. Now, there are some fun water experiments that you can do. So I want you to try some of these at home as we go on as a closure to water science. Let's continue with a trivia question and then let you answer it at home. I'm not going to give you the answer. What boils faster? 1/2 gallon, or that is to say, 2 quarts of water. What boils faster? Cold water or hot water? If you put a 1/2 gallon of cold water in a pot, which would boil faster, cold or hot? So I see some answers coming in here. Hot water. Some people think the hot water will boil faster. And also, you can't do this in Florida very well. Which one freezes faster, hot or cold water? The answers there might surprise you, but you can try it. Take a pot of hot water, put it in there to boil, and then take a pot of cold water, the same amount, and time it. Use a timer. You got some time this afternoon. You're not doing anything else. You want to know, don't you? Well, you find out, you do the experiment, you do the work, and it might surprise you. Once you're done doing the experiment and the work with your worksheet, and you filled it all in, make sure your name's on it, turn it into the director, and you'll get credit for water science. And you guys did real well. A shout out to the Pathfinders that were watching here. Thank you from Camp Kalakwa for spending time with us today.